So I welcome you guys to the third episode of our further mathematics for SS2, and today we are going to be starting with propositional logic. Now I want to talk about propositional logic. It's all about the using of proposing statements and symbols. So when I say proposing, I'm talking about the fact where you are trying to bring forward a statement, and that statement is either true or false. So in this case, for example, let's have an example here. So we have these propositions on the screen here. So these propositions, we have a proposition, yes, is a proposition or statement is a verbal or written declarative sentence that is either true or false. So as I mentioned earlier, and then for example, 4 plus 5 equals 9 and 2 plus 2 equals 5 are both propositions or statements. Yes, that's true. And then why the first statement is true, the second statement is false. Yes, that's basically the concept we're trying to make it. And then the truth or falsity of a statement or proposition is called its truth value. And a true statement has a truth value T, while a false statement has a truth value F. And consider the following declarative statement. So for example, you have this declarative statement. The earth is a planet. So that is either true or false. Then 3 plus 4 is 8. That is either true or false, but you know it's false. Or don't you? Then also have 8 elements of the set 7, 8, 9, 10. So in that third example here, that is typical to set, which we've covered in the previous course. So that one is trying to ask us that, okay, is 8 an element of the set of numbers that include 7, 8, 9, and 10? So obviously 8 is included, so that will be true. Then we also have the number D, which is, are you a Nigerian? So well, for me personally, that would be true, but I don't know of you. So then we also have x plus 5 equals 9. So in that case, we have to solve it and get the truth value, which will be 4. Then we also have come out. That is not a statement. That is basically just a command. So that can either be true or false. So we are looking for which ones are statements and which ones are not. So what a grade is, that is just an exclamation. This is not a sentence. It's not a statement. It's a sentence, but it's not a statement. So a sentence is different from a statement in that a sentence is just anything you can say, but a statement basically must either be true or false. And there are different levels of restrictions on the statement to make it a propositional logic. So that's basically what we're talking about. And let's move on to something else. Just in case you don't know the concept of propositional logic, of predicate logic, yes. We have two kinds of logic. We have predicate logic and we have propositional logic. We'll be talking about propositional predicate logic in another episode. But let's deal with truth tables. Yes. So in this course, we are going to be dealing majorly with truth tables. Let's talk about the basics of truth tables. Now there are different major types of truth tables we can be dealing with. We can talk about here. So let's talk about the first kind of truth tables, which is the not table. So for example, if we have a statement T, okay, let me not use T. If we have a statement R, now this R could either be true or false, right? Now we can construct a truth table for R, so in such a way that we have a truth table, and this truth table is a negation truth table. So we have a not R, which is whatever that sign is, and then when we have R as true, the not R will be false. When we have R as false, the not R will be true. So that is basically one concept I need you to understand. The negation is always the opposition of something. So you can write it down, you know, that is the negation table. Then we also have the let's call it the conjunction. Yes, conjunction is also known as the AND table. So for example, if you have the statement R and the statement R has 4 different, we have statement R, a combination of R and S. Now R is T, true, true, false, and false. Then S could be true, false, true, or false. So in this case, now we have R and S, and that is denoted by an inverted V. R inverted V, S. That is the symbol for conjunction. Now for conjunction, a conjunction is only true when both statements are true. That is when both premises of a particular logical statement are true. So for example, if R is true and S is true, then the AND conjunction will be true. But if one of them is false and the other is true, if they are not the same, it will be false. And also, if they are both false, it will be false, because that is an AND. So that means they have to be true. So the only time when an AND statement is true is if both are true, but otherwise it will be false. So it is a very strict kind of statement. Then we also have the or table. So basically, it's similar to the and table, but in the sense that we have R, we have S, then we have R VS. That's the and symbol. So this V is not inverted, it is normal V. So it will be true, true, false, and false. We have true, false, true, and false. So in this case, when there's at least one truth, a single truth in each of the premises, then the conclusions will be true. For example, we have true and true, so it's true. Then we have true and false, but because at least one of them is true, so we will still get true. So we have false and true, because at least one of them is true, we still get true. Then false and false, because no one is true, we get false. So the only case where you get false is when both are false in this whole table. It is less strict. Then we also have the basically it's called a conditional statement, and in this case it is an if statement. So we have it as here. We have, if they have this as R and we have this as S, so that means we have the conditional statement as R implies, it's called an implication, R implies S. So T F T F true. Now this T and S I'm writing, they are trues and false. Now this kind of thing, they are basically typical with computer systems, just in case you don't know. Now when you say R implies S, you say if true implies true, then it is true, but if true implies false, then that is false. So we are basically concerned with the final answer here. Then if false implies true, we don't care, it is still true. So here we have false, here we have true. Then if false implies false, then they are both false, which is false. So the only case where this is true in two cases. When they are both true, or when the last one is true. That's the two cases where your implications or conditional proposition is true. Then we also have the biconditional proposition. So in this case, let's draw the truth table for it here. So I have the R and S. Biconditional R. So it has a double-sided arrow. S T T F F T F T F. So first of all, we have this basically when the biconditional statement is only true if they are both true at the same time. For example, if they are both true and true, then the biconditional statement will give us a result of true. If they are both false, which is false and false, the biconditional statement will also give us an answer of true. But if they are different, then they will be false. So in this case, true and true will give us true, true and false will give us false, false and true will give us false, and then false and false gives us true, because they are the same at the false and false point. So these are the basic different concepts. Let me give you real life examples where you can be asked to talk about this concept. So in the first note, I can say I am a teacher. Then you can tell me that the negation of my statement is I am not a teacher. So in the second example, it's a and proposition, right? So in this and proposition, you have R and S. So that means if I say I like teaching and coding, yes. So and that is kind of like an and proposition. So the first statement is I like teaching, and then the second statement is I like coding. When you combine them together, they give you I like teaching and coding, and that is an and. So we also have the or proposition. We have I like teaching or singing. So this R has teaching, and then the S has an I like singing. So it's either you like teaching or you like singing, but not both of them at the same time. So that's an or. But it's still allowed to be both of them at the same time, because here you have true and true. When they are both true, then it's still true. Now also finally we have the conditional statement. So we have R implies S. So that means true and true implies true, true and false false, false and true true, false and false false. So that means it is basically an if and else, if else, if else. So for example, if it rains, I won't make this video. So if it rains, then if it rains and I made this video, then it is actually right. So if it rains, I won't make the video, right? Okay, well, let's make it positive. If it rains, I will. Okay, if it rains, I will have a bath. So if it rains, true, I'll have a bath, which is true. If it rains, I will not have a bath. So basically, if it does not rain, I'll have a bath. If it does not rain, I will not have a bath. So basically, but that's, even though it might not make a lot of sense now, but mathematically it still makes much of sense. Let's go to the equivalent statement. So we have T. So It's basically all equilateral triangles are equiangular triangles. So if it's an equilateral triangle, it will also be an equiangular triangle, which will be true. And if it is not one of the two, then it will be false. But if it is not an equilateral triangle, then it is not an equiangular triangle, which is also true. So that is an example of equivalent statement. So basically, I hope you understand this concept, and I hope to see you next episode.